Finally, we need to talk about reflexes. And I'm going to go through some major reflexes, even though it's not a huge topic in the book. And I know that this is a lot this week, so I'll try to keep this really straightforward. A reflex is a fast, involuntary, sort of automatic response to a particular stimulus. Like if you touch a hot stove, you're going to jerk your finger away very quickly. This idea is that a reflex is sort of protective. It has a really quick response that's kind of pre-programmed in the spinal cord, so you don't have to think about it because it just saves you a split second. There are somatic reflexes, which are skeletal muscle movements, and there are also autonomic reflexes, which involve non-skeletal muscles. We will be addressing the whole autonomic system next week, so hold that thought. The pathways of a nerve reflex arc are always 5 components. A sensor, right? A sensor of some kind of stimulus that triggers a nerve impulse. We have a sensory neuron that's going to carry that impulse. There will be an integration that occurs, and that can either be an interneuron, so you have like a middle neuron between the sensory neuron and the motor neuron. There could be some reflexes that actually are so pre-programmed that they're hardwired in sensory to motor and they don't even need an interneuron. But usually these are polysynaptic and do involve an interneuron. That impulse is going to be transmitted to a motor neuron, and then the motor neuron is going to travel to the effector and then deliver the action. So we got to sense the stimulus. We have to carry that action potential impulse. We have to have the processing. It's either going to interface through an interneuron or directly to a motor neuron, and then that motor neuron will carry out the effect. Now, if you see the term ipsilateral reflex, that means the sensory and the motor neuron are on the same side. The sensation comes into the same side as the spinal cord. The motor output goes out the same side. We also have contralateral reflexes where there will be a cross. So the sensation and motor neuron are on opposite sides. And I think the best way to kind of illustrate those is just with an example. But think of ipsilateral as same side. Contralateral is opposite side. Now here's just a illustration of that arc. We have a stimulus, in this case pain. We have a sensory neuron carrying that impulse into the spinal cord. We have an interneuron here that is going to translate the decision to a motor neuron directly. Brain does not need to know. It will know if it's pain for sure. But usually a branch of the interneuron would let the brain know. The effect is immediate, that it's going to signal the motor neuron to move that part of your body off of whatever that painful stimulus is. So, those 5 components. We're going to start with the stretch reflex, which is super important. The stretch reflex is kind of what you use a reflex hammer with. This is something that is done all the time, like in a pediatric checkup, just to kind of measure reflex response times and stuff like that. Here's how it works. In this case, the stretch is actually happening in the muscle. So in the stretch reflex that we're testing here, which is the patellar stretch reflex, the reflex hammer pushes on that patellar tendon and it kind of pulls that tendon. That pull creates stretch in the muscle where that sensory nerve ending is embedded into the muscle. That's going to trigger an action potential like, oh my gosh, I'm being stretched. That signal comes in through the dorsal side of the spinal cord. You can see the dorsal root ganglion there, the dorsal root, and there are 3 collaterals. There are 3 branches, okay? You're definitely aware that something is hitting your knee. So one of those collaterals is just going to tell you that up at the brain. We are also going to have one collateral directly synapse onto the motor neuron. The stretch reflex, the reason why we're interested in this is that it is kind of your very hardwired response. Super important. We do not need an interneuron. This is a monosynaptic pathway where that same muscle is going to get a motor neuron to signal it to contract. Because what happens when you get hit on your patellar tendon? this muscle contracts and your leg jerks up. So your quads are actually contracting. So this branch, motor neuron, is going to contract those same muscles that were being stretched. And I want you to remember that sarcomeres, if they're overstretched, it can damage them. So if there's an unplanned stretch, the reaction should be to stop that stretch. How do you stop it? Shorten it, right? Let's go back to these collaterals. We have one to the brain, one to the muscles that were being stretched to basically contract them. And there's another collateral here too. In the middle, there's a collateral to an interneuron. And this interneuron is actually going to hyperpolarize the antagonistic muscles, in this case, the hamstrings. Why? Well, when your muscles contract, they actually produce a lot of force on the bone. You never want to have opposite muscle groups contract at the same time because they could harm the attachments to themselves. They're actually strong enough to rip themselves off the bone. So when we have the quads contract, what we want to do is make sure that the hamstrings do not. So we're going to excite the quads, and then we're going to hyperpolarize the motor neuron that would usually signal the hamstrings, the opposite muscle group, to contract. So this basically ensures that only the quads are activated and they are going to contract, and then you get that little jerk reaction. By the way, you do not need a reflex hammer to test this. You could just use your fingertips. You could just kind of cup your fingers and kind of right underneath your patella, right underneath your kneecap, you could kind of hit that tendon. You should be able to elicit this reflex. So I've written it out for you. The stretch reflex itself, the direct pathway is monosynaptic, right? You just have sensory to motor neuron. You get that same muscle group to contract. It's the polysynaptic part that goes to the interneuron, also stimulated. In addition to awareness is definitely going to, the brain definitely wants to know that something's happening. Shall we do the next reflex? Next reflex is the Golgi or tendon reflex. I like tendon reflex because it kind of tells you where the sensors for this particular reflex are. They are embedded into the tendon rather than the muscle fibers themselves, which would be the stretch reflex. But what these sensors are looking for is actually tension or tightness. If a muscle is really contracting very hard and shortening, remember, a sarcomere can also be damaged if it's over-shortened. So this is sort of like our defense of over-shortening damage. These sensors are monitoring that tension from a contracting quads, in this case. That sensor is going to come in through the spinal cord, cute little dorsal root ganglion there. And then we have 3 collaterals again, one to the brain, so you are going to be aware of this. And then one collateral will synapse onto an interneuron that actually will inhibit that muscle from contracting anymore. That's very helpful. It will actually paralyze that muscle so that it can't hurt itself. We also have another collateral, which will, in this case, synapse with an excitatory motor neuron that will start to engage or contract the antagonistic group. So in this case, we actually do want the hamstrings to start to engage so that they're kind of counterbalancing what is happening in the other over-contracting muscle group. So we have tightness in this initial muscle, like from over-contraction. That sensation is going to travel in through the spinal cord, split into 3 branches or collaterals, one up to the brain. One interneuron will actually inhibit that same muscle from contracting anymore. And then we have one collateral to an excitatory motor neuron in the opposite motor group. That'll start to activate and contract, which will kind of produce a counterbalance to that over-contracted initial muscle that is too tight. Here's all the details about the tendon or Golgi reflex. It can override stretch. It's ipsilateral. We've got sensors in the tendon versus the muscle. we're going to see that the collateral sensory neuron will activate antagonistic muscles to start to engage. That just kind of counterbalances any muscle group from going too far, too tense, I guess. And then the original muscles that are overcontracting are going to have inhibition, so that also kind of starts to paralyze them. And this gives us balance, so that we don't want to overstretch our muscles, but we also don't want to over-tighten muscles. Both of those can result in damage. All right, we have another reflex that is going to take a couple of slides to get through. It's called the flexor cross extensor, and this is our first contralateral reflex. There's ipsilateral parts to this reflex, but it's kind of interesting that it also includes contralateral for a change. So, and here's kind of the scenario. Let's say you're standing and you hit a Lego or something really sharp, and you have this reflex to kind of pull that leg away. Well, your other leg is going to need to, catch you from falling, right? So you pull one leg up really fast, but then you compensate on the other side of your body so you don't fall. So this is complicated. This is going to involve both sides of your legs, and it's going to involve lots and lots of muscles. In the previous two reflexes, the stretch and the tendon reflex, we really just saw one muscle, right? Maybe two groups, but like single muscles. So in this case, we're going to see we hit their pain here. We've got our sensor that's going to come in through the spinal cord. And the reason why there's 3 slices of spinal cord here is that our sensory neuron is going to interface with an interneuron that goes up and down the spinal cord. And this is going to allow us to activate many different muscle groups, right? If you think about jumping off of a Lego and catching yourself on the other foot, it's going to be your thigh muscles, your abductors, your lower leg muscles, feet. You're talking about dozens of muscle groups that get activated from different parts of your spinal cord. So this is just illustrating that. We have our initial sensor coming in, and here's kind of the initial part of this reflex in the middle. We have one collateral that's going to have an interneuron. It's like, oh God, this really hurts. I need to pull this leg up. Okay, well, this is going to go right back to the muscle groups that need to kind of be involved to pull your foot off. But it's also going to have a collateral that will travel up and down and engage other muscles that are maybe higher or lower in terms of where they emerge from the spinal cord. So it's not just the hamstrings, it's going to be all of the muscles, but this basically gives us this leg response that jerks off of that particular stimulus. So the only thing new here is that we have multiple muscle groups all being activated at the same time, because one of those sensory neuron collaterals is going to travel up and down and activate other muscle areas. Now, here's kind of where it gets interesting. We have our stimulus and our leg jerk reaction, that's ipsilateral, but we also have our contralateral catch us on the other side. I think when anyone asks you what you learned about today in class, you should just show them this picture. Just be like, this is what I did. This is nothing. This is it. This is why I didn't want to show you this picture at the beginning. It's a little bit overwhelming. Let's start at the beginning. Let's start with where we just were, which was the sensation of pain coming in through a sensory neuron, little cute dorsal root ganglion cell body there. Coming in, we have our synapses with an interneuron here that's going to travel to other muscle groups, as well as directly at that level of the cord to basically move those muscles that are going to pull that leg off of that painful stimulus. This is the ipsilateral response, moving that leg off of the stimulus. Notice that we also have some interneurons that are going to decussate through the gray commissure or cross over to the opposite or contralateral side of the spinal cord. These are going to be controlling muscle groups on the opposite leg. So, while this leg is going to pull up, your other leg is going to have muscle activity to catch you from falling. And this is actually the pathway. We have sensory coming in. Just follow each one. We've got collateral, collateral, collateral. This one is for an interneuron on the ipsilateral side for that same leg. These ones that are going to synapse with interneurons that decussate or cross over are just going to activate the opposite leg, but they are appropriately programmed to basically engage all of the muscles on the contralateral leg to catch you so that you don't fall down. This is the flexor. Ideally, your pain leg would be flexed off of that particular stimulus, and your opposite leg would extend as it is keeping you from, falling down. Flexor, cross extensor. That was a fun lesson.